Hello again, this is Math 2115 Remote Delivery for April 14th, 2020, and this is part 1. Make sure you use tools like this pause, rewind, and play button to make sure that you understand what happens as we go through. My favorite teacher in high school made us memorize the poem If by Kipling. And this is not the whole poem, but I think about this often. That's actually why she's my favorite teacher. I find a lot of comfort in this. I'm going to recite just a bit of it with you here because I think it applies very much. If you can force your heart and nerve and sinew to serve your turn long after they are gone, and so hold on when there is nothing in you except the will which says to them, hold on. It concludes later, yours is the earth and everything in it. Well, you see, it is not easy right now. I'm sure it's not easy for you, it's not easy for me, and we're working through difficulties. But if you are able to stay engaged in spite of your circumstances, I am confident that teaching and learning can continue unabated. Grades will be earned and rendered, and your educational goals need not be deferred. I hope you are able to stay the course because that's what champions would do. Also in today's lecture, I'm going to adopt a COVID-19 contingency. This was a great mathematician. He did things with algebra, matrices, and quantum mechanics. And this is the guy who said that. But he says, we're not very pleased when we're forced to accept a mathematical truth by virtue of complicated chain of formal conclusions and computations, which we traverse blindly, link by link, feeling our way by touch. We want first an overview of the aim and of the road. We want to understand the idea behind the proof, the deeper context. A couple of times today, instead of doing the detailed technical proof, I'm going to kind of wave my hands, so to speak, and talk about how is the proof supposed to work. And I think you walk away with an idea of the proof, and the technical aspects could be looked at later as you need to do so. So let's begin. A graph is said to be circuit-free, and sometimes it is also called acyclic. If and only if it has no circuits. A graph is called a tree if and only if it is circuit-free and connected. A trivial tree is a graph that consists of a single vertex. A graph is called a forest if and only if it is circuit-free and not connected. So that's a big definition, and we're going to be studying trees during this lecture and probably some more as we go forward. So this is a good place for you to test your understanding. Hit the pause button and figure out, are these trees or not? Let's see how you did. All of these are trees. Hit the pause button again. Are these trees or not? And explain why. Let's see how you did. None of these are trees. This has a cycle, that has a cycle, that has a cycle, and this is not connected. So I think you're getting a handle on what is a tree and what is not a tree. Let's look at an example of something that happens in college placement, and this is an example of a decision tree. And so I'm going to explain this, and then I'm going to ask you to answer a question in just a bit. But we have a student who takes a two-part placement test, or potentially a two-part placement test. If his score is really bad on part 1, he gets placed into this course. If he gets placed into these second areas with 8s, 9s, or 10s, or greater than 10, he will take a part 2. And part 2 then, there are decision trees that go further and further, and eventually we place the students in a math course. So my question for you now is, which course should be recommended for a student who scored 9 on part 1 and 7 on part 2? Please hit the pause button and let's see how you did. Let's see how you did. The student should be advised to take Math 110 for these reasons. That is the end of part 1. I'm slicing this into slices, so that's part 1. There will